Good morning and welcome to day 2 of the Persistent Memory and Computational Storage Summit for 2021. Wanted to spend a little bit of time today going over some of the logistics of the event since we're kicking it off. My name is Scott Shadley. I'm a member of the board of directors of SNIA and also a marketing guy for NGD Systems. So first off, shout out to the sponsors. We appreciate their support of the event. Don't forget there's opportunity to visit their conference rooms and talk to them through the Slack channels. They'd appreciate your attention and happy to follow up with you on any of the content that's been shared at the event this week. Quick reminder, yesterday's agenda is available on demand. All of these sessions will be available, and you can see that we covered both persistent memory and computational storage topics very well across the course of the day. If you missed any of those sessions, please feel free to look those up, and we'll be able to show those to you on demand. As far as today goes, we want to spend a little bit of time just highlighting their continued topic coverage for both persistent memory and computational storage. And don't forget to stick around. We're going to have a great recap of the day as well towards the end of the sessions and look forward to participating in that as well. So if you enjoyed the idea of being a socialite like I do from time to time, don't forget to take advantage of the Twitter handles and the opportunity to ask questions about the summit. Hashtag SNIA PM+CS is the official hashtag of the event, and we will have the Slack channels running as well. So if you have questions for me during the rest of this presentation or the content that's being shared today, feel free to let us know, and we'll be able to follow up with you on that information. So with that, I want to get into today's topic, the computational storage market. So as you all know, I'm an NGD employee who is a pioneer in this particular space, but today I'm taking more of the SNIA hat and trying to bring what is computational storage, if you will, to those that may not be familiar with it from a perspective of the summit. It's the first time we've brought the technology in. And so it's an opportunity for me to give a little bit of a history lesson and what it takes to bring a new technology to market from more of a marketing point of view. So SNIA does a lot of great technical work. CMSI, as you know, is the underwriter of this event, is doing all around the marketing capabilities of the technology and market space. So we wanted to do a little bit of that. If you're more interested in the techie stuff, we'll certainly have those as well, and I'll give you hints on how to find that information at the end of the presentation. So today I wanted to talk about driving nothing to something. Everything that gets innovated in this place and any kind of future technology has to start somewhere. And there's a lot of things that can be done, created, developed, deployed, and no one knows anything about. And there are some that get created. Amazing technology never gets to, quote, mass adoption because it doesn't have the traction needed. So I kind of have this this diagram of the 4 little puzzle pieces that go together. You need a product, some sort of product, software, hardware, anything that it requires to make a technology work. You need to be able to get people knowing about that product and how it's innovative. So that's where you get into the concept of education and support. And then there's all this concept of industry collaboration, and that's exactly what SNIA represents in this particular example. So you can't build new products in a vacuum. You have to have collaboration. You have to have marketing, which also includes things like education. And you have to have products that can be delivered to the market. In case of computational storage, we're in the process of this evolutionary effort. There are already products. Some startups exist. There's been R&D projects over the last few years. There's lots of materials around marketing and education where it is, whether it's through SNIA or through the vendors that we're going to introduce to you today, including some of my friends in the marketplace. And the collaboration of not only SNIA, but other working groups as well. We have a wonderful alliance that's worked with the NVMe, or Non-Volatile Memory Express organization as well. And I'll give you a little bit of heads up on that as we get going. So what does it mean to do this? I kind of look at it from a perspective that it takes a little bit of getting the word out. So I'm going to give a little bit of background on where computational storage came from. It's fairly commonplace for me and a lot of the people in the space, but we know that there's still quite a few folks out there that don't quite know where it came from. So information sharing is key. As a marketing guy, that's my job. I'm supposed to share, I'm supposed to educate, I'm supposed to make things known. The trick is if you have a whole bunch of different people talking about the same information in very different ways, you can and will lose the ability to understand what's going on. And you spend more time trying to introduce a topic versus getting something deployed and adopted and delivered into the marketplace. So what we did with this is get together a couple of the companies back in 2018 and put together a computational storage working group initiative, and it became a SNIA computational storage technical working group. Prior to that, we had all kinds of names for this technology. One was called scale in, another one was called in situ processing. Another company used the phrase compute to data. Another company used in data processing. All of them represented what we now encompass as computational storage. And so that ability to bring all that information together is one of the aspects of what industry collaboration is key and important about, and why we're talking to you today as part of the SNIA Summit and what's going on. Now, it's great when I'm a vendor and I want to sell it and I get some other vendors to use the same term, so we all go into the same customer if we're in a competitive environment, that they understand at least the term and the technology. But there's more to it than that, because it's one of those, you can take my word for it, but don't just listen to me. Ask the experts. We have a lot of technological development that's been done in this space for computational storage that you may or may not have been known is available, if you will. So we went together as a bunch of different companies and we engaged industry experts like Gartner, IDC, 451 Research, TechTarget, who recently acquired ESG, for example. 451 was recently acquired by SAP Global. They're all driving information about what's going on in the marketplace around this concept of computational storage. And this is necessary because you don't want to just take my word for it. You want other people to agree that this is something that's valuable for the market, useful for the market, and can actually drive attention and detail. So working in a collaborative environment and engaging these analysts is a big picture piece of what's taking place. And how that comes to fruition is very visible through one of our great partners in the way of Gartner. And I have the ability to here showcase that there's some unique opportunities that exist for computational storage, not only from the fact of where we are in the engagement cycle. So you'll see here is a bunch of different articles that have been posted, and they were all within the last 24 months. So it's fairly recent that this technology is gaining that traction. And I already mentioned it started back as early as 2010. So we're getting involved through this life cycle, or in this case, as you can see on the right-hand side, the hype cycle. The hype cycle represents the view from one industry analyst, Gartner, on how technology adoption takes place. Now, historically, a lot of technologies have sat on one of these hype cycles. You can see here, the lower hype cycle represents storage and data protection technologies, while the upper one represents compute infrastructure. This is one of the few technologies that's ever bridged both of those hype cycles with one type of technology. And that's because of the innovation that comes as part of being this thing, computational storage. Why is that? Well, we'll get there in just a second. So if you're interested in looking at some of this information, there is ability to get access to some of it online. So feel free to let me know in the chat or follow up after the event. So not only is it important to get that engagement and get going beyond that, but it also takes a lot of work of getting it beyond the press itself as well. So you can see here, we started things very humbly, and you can see on the graphic there in the middle of the page, one of the originating computational storage working group lists compared to what we are now today. So we went from a handful of companies getting together and saying, hey, let's drive this, to now well over 46 companies and over 200 individuals from all those companies. And the promise that's provided here is by working with these industry experts and getting them to write about the technology, getting them to acknowledge it and help push it and introduce it to their clients, we get the ability to not only have just vendors or potential vendors, but a lot of our customers and the people that will actually deploy this technology into the marketplace are part of that 232 people that are now helping drive into a standard. And so the more engagements, the more points of view, the more products come to market. And then you start to see more happen in the marketplace as well. So this next page talks to the concept of not getting just our word for it. So I've got a bunch of different industry articles that have been posted back to 18, 19, even as much as just early in 2021. And some of these are from third parties, some of these may be sponsored, and there's even some that are from our customers. The center one there you can see is from Dell Technologies. They're a member of the working group. They'd be a consumer of this end product that's being developed. And along the bottom there, you can see 3 of the vendors that have worked with partners to bring solutions to market. So we have ScaleFlex with the distributing partner. I did a comm with a hardware partner. Samsung got together with Xilinx for their FPGA products. And my company got together with a company called Trenton Systems. So we get this ecosystem that starts to evolve. And among all of this, you'll see that fancy little eagle there in the middle, the EMC3. That's actually Los Alamos National Labs, the government lab group that's in charge of high performance computing evolution for the US government. They're involved as well. They've made several announcements and will continue to do so. And they even participate now in the efforts to help drive these technologies forward. And if you missed it, there was a presentation from Brad Saddlemeyer yesterday from Los Alamos National Labs about his view on computational storage technology. So feel free to check that out. So from a technology perspective, we want to talk about what's going on, right? So we have 2 different working groups that are taking place in this right now, SNIA and NVMe. You can see here that there's been some work that's been done. So we've created some definitions. It's always good to have common language. We've started some architectural work. There's currently a public review document available on SNIA.com. We're working on, or SNIA.org. We're working on an updated version of that as we speak. And when we get into that, we start talking about, well, how are we going to do the interfaces? So SNIA does a great job of looking at architectures, looking at standardization of ways of communicating with devices. NVMe is a specific protocol implementation of that. And so the Non-Volatile Memory Express group is actually driven a technical working group as well that is working towards computational programs as well. And then we start talking about, well, how do you use it? Okay, so we get into things like an API or software programming models. And of course, the new one that's come up and was also part of a panel within this event was the concepts of a threat model and security, what we have to do around that. So there's a lot of effort still going on within the industry. We're still evolving, it's still developing. All of this is background and history on what's been taking place and how we're getting this technology into the market. Now what I want to do is spend a little bit of time. Gave you the background, you're caught up to speed. Now what's it take to make this stuff work? And that's really where we get into some of the fun. And so I'm going to start talking to you a little about productization. And whenever you talk about productization, what a product is, software, hardware, anything that you're bringing to market, you want to know why you need it, right? It's why am I here? What's in it for me? Why do I care? It's like, I can sell you an iceberg to an Eskimo, but does that really work for us? Well, depends on what the iceberg is doing. So, leading the witness here. IDC predicts that over 175 zettabytes of data are going to be churned out in 2025. That was something they published in 2017. To be honest, they revised that this year, and it's over 250 zettabytes in 2025. That's a lot of data. Data is storage products. Hey, look, we're halfway there. We're halfway to our solution. Now what's coming next? We're moving everything from cloud to edge, and we're trying to make the edge more intelligent and the edge smarter. This is a great opportunity, and things like NVMe and PCIe Gen 3, 4, 5 all bring these opportunities to bear, but they're transport solving problems. So NVMe solves a great transport problem. PCIe getting faster solves a great transport problem. The issue that we're running into is transporting all that data is not really what we want to do. And so if you look at the data iceberg there, for example, you can see the concept of primary storage versus secondary storage. Out of that zettabytes of data that we're generating, we only really want megabytes or gigabytes of useful information that comes from that massive amount of information. So we want to store it. We want to gather that raw data. We want to be able to do things with that raw data. Where we work on that raw data is truly what's coming to market and coming to bear. And a brief example of on the bottom left there, you can see this inner workings of a computational storage drive. I highlighted in yellow this concept of raw data versus green being processed data. Computational storage drive solutions are the culmination of being able to take in massive amounts of data and only transferring out data that really has value. That's the net win, if you will, of computational storage. Being able to process data in close proximity to where it's stored so that you don't have to take advantage of these very fast transports. Let them do the work they really need to do. You can see my fun little graphic here about NVMe. Great solution. I love it. I make products in the space, but it still just moves data. It doesn't actually work on it. And that's what we're trying to solve with a lot of this effort. Even things like NVMe over Fabrics and NVMe OF, again, a great way to work about moving data across the network in a seamless fashion, but let's stop moving so much data. Now, when we think about productization, we have to making the product can be very easy. Getting people to buy it, adopt it, that's where we start running into some fun, right? So think about it in the history of interface protocols for all the storage devices we've had today. You can go back to PATA, SATA, SATs, PCIe native, and then NVMe. And we have things coming forward now that's part of this event, for example, with the opportunity to bring interfaces like CXL into the play. All of these require some form of drive and attention, something to bring them to bear. I'm going to bring up a good example of a historical product from Fusion.io. They invented the world's first PCIe SSD. Great product, but to deploy it, I had to change my kernel. I had to do a lot of work. I needed to do a whole bunch of things. It wasn't plug and play. So we need to be able to get to solutions that become more available for people to plug and play. And that's kind of what we're doing with the SNIA Computational Storage Working Group. Now, the bottom left shows a graphic of what would be classified as PCIe adoption rate and shipment share. You can see that there's a hockey stick involved. And that hockey stick comes into play because of things like NVMe and NVMe over Fabrics. PCIe is a great technology. It's a great opportunity to adopt things. But when I have to do major change to a product, major change to a software, or I have to change a kernel, Well, you bring in security, you bring in a lot of work, you bring in validation and verification. So the idea of computational storage from SNIA and NVMe both is a way to common and create a seamless way of interacting with these devices. Now, I mentioned that there are already some products in play today. So there are certainly market-driven products. You can see that there's a lot of different ways you can build a design. So these both represent graphics that have been shown by the technical working group at previous storage developer conferences. The top one shows a graphical rendering of how products are put together using FPGAs and SSDs and ASIC-based solutions and various different ways of deploying these products. One of the common themes is the interface. Most of those are NVMe based. Some are PCIe based. All of them provide a way of driving a new technology to market in a fashion that's easy and somewhat seamless to deliver. The simplification of the design comes to the choice of the vendor and what you would like to do with that particular product, what flexibility is needed. Now, down below, you see the architectural rendering idea, and this is something that came out of the current public review document from the SNIA Technical Working Group. I will let you know right here and now that this is going to be changing because we are evolving. We went from, a handful of companies to 46 companies. A lot of different minds came together and realized we can make things better. So you'll see some changes coming to that as we release the next version of that document, hopefully within the next few months. And bringing it to market and driving it has to do with this concept of, common API, seamlessly able to program it, and plug and play capability. And that's really what we're driving for with a lot of the work that's being done within SNIA and NVMe, and even the vendors themselves, because each of the vendors are evolving their products. We all have roadmaps to future solutions. And I want to be vendor agnostic in the next slide as much as humanly possible. So I did highlight all of the existing products that are shipping today that claim and or are classified as computational storage. So top left, you can see Samsung got together with Xilinx and created a product that they trademarked called the Smart SSD. Dead center, top of the frame, you can see ScaleFlux. They produced what they call the Computational Storage Driver, CSD. They're on their second generation. They recently talked about a third. Top right is my product. You can see it comes across the same thing, multiple form factors. We all have this 2.5-inch drive in common. Again, seamless and easy to plug. We offer an opportunity with a couple of other solutions because of an ASIC-based design to get into the newer form factors like EDSFF. You can see bottom left, Bitware designed products from Iditacom support, and those are, again, all in 2.5. They also have an EDSFF. Those CSP products are great. Down bottom center is a product from IBM. They call it a Flash Core module, and that particular product is also offering a computational storage-like resource in the way of a compression algorithm for their product for their customers. So they claim they are classified in the same space. And then the bottom right is a product from a company called NetInt that actually does transcoding inside the device. So incoming raw data stream transcodes to whatever you're looking for as it's stored. So all of these products are bringing different ways to deliver a product to our customers. Most of these today are NVMe plug and play. There are a couple that require some other changes today, but they're evolving their ecosystem. Many of them, as you can see here, are FPGA based. A couple of them are ASIC based. So we're seeing a variety of different products that are being driven and designed into the solution set. So the opportunity exists to continue to evolve these. And the goal is every one of these companies listed here are participating in the efforts to make sure that you as our customers and those that are looking to enable these or design with these or play with these products and turn them into something else have a common way to communicate with them, a common way to discover what they offer. Because we don't all offer the same resources, we don't offer the same products, but we offer an ability to drive to the end solution, which is move less data, get results faster, and start freeing up network traffic because we're not moving that data as much. So what are we looking at it from a keys to success? I look at this as driving adoption with driving standards. There's a lot of different things that can take place. I've mentioned already a few of those. Plug and play, seamless programming. The programming model is huge. If you don't have an easy way for someone to go, I got it, and have that light bulb moment, it creates more challenges and work for you. And this common interface is very important. So we're very excited about the collaboration that we have with the Non-Volatile Memory Express group and how we're coexisting in the space to help develop products for our customers. Another piece of it, we do have to look at it, and I'm a marketing guy, I hate to use the word cost because I love to charge more for it, but pricing does have an impact on it. I've got two examples here of how pricing and or marketing and the whole conversation of how to get it next steps is in play. STEC designed a drive back in the day called the Zeus IOPS drive. That company got acquired by Western Digital because of the success that they had. But that little drive right there was 73 gigabytes of data, and it ran about $30,000 when it first came out to market. Little bit of cost prohibitiveness. So we've had to rethink the marketplace, design products that don't have as many parts, go to ASICs so that you can keep costs down, all those types of solutions to help bring that forward. And then having strong roadmaps and aligning to technologies. We've seen a lot of electric vehicles in our lifetime. We've seen a lot of different hybrid devices in our lifetime. And until recently, with the initiative around green architectures and going green and carbon neutral, they really didn't start getting traction until you had someone come out with something like the Elon Musk Tesla roadmap. It was simple, it was straightforward, it had a mission, he was going to deliver it, and he worked on it and brought it to market. Now, I will have to admit, he did it a little bit on his own, so it kind of defeats my little, work together collaborative piece of it. But at the same time, the ability to drive a strong direction and a strong marketing message is key, and we can do that together in computational storage. Because if you build it, they won't come unless you build what they're looking for, and that's exactly what Tesla did, and that's exactly what the Computational Storage Technical Working Group is coming together to do. Now, I've talked about products, I've talked about what's next. There's another big piece of this, and that's my customer, and you as my customer, or your customers who may buy a product that you're going to buy with computational storage in it. So first innovations don't always win. We've seen that happen. We've seen wars of different products that come to market where not necessarily the better technology, if you will, won. HD DVD versus Blu-ray, for those that are old enough like me, VHS versus Betamax. You have all these different things where one wins because the market got behind it. One lost, not because it was a better technology, but because they didn't have the same traction. So that's very important for the idea of computational storage, and one reason why we're not looking at this from a competitive landscape point of view, but how do we bring technology to bear? Again, all the products today deliver different solutions, so we're not competing with one another. We're all solving different customer problems today as we drive forward to make more commonplace architecture come into play. Now, first customers, raise my hand. I want to be the first guy to do it. Great. We need those. We love those. All of the vendors that are working in this particular space that have products have those. The reason we need those is because there's a lot of people that like to be fast followers, and fast followers look for the things that make it easy for them to deploy. Now, if we look at the whole ecosystem that exists today in the storage architectures, cloud versus edge versus all this kind of stuff, you certainly have people that are powerhouses and they can do whatever they would like to do, and they will deliver a product, and then other people will be like, oh, that's pretty cool. How can I deploy that? That's how I look at it from a first customer versus fast follower. You need customers to make products work. Great engineered designs do not always make it to market. And I have several of those in my history as an engineer where I developed a technology for a company I worked for that never saw the light of day, just simply because the effort wasn't there, the market didn't get involved. So flexibility of design is imperative for these products. So you have to have products that can flex with the change in market. So for example, we're bringing an API to market. If some of these current vendors don't align to that, it could create a roadmap problem for them. But because they're participating in the effort, they get the opportunity to make sure that their products solve that situation. Vendor unique is a great thing for some folks. It is a lot of things for being able to lock in customers, but then again, vendor lock-in is not something that's very favorable today, so that's where the collaboration comes in. We're all about collaboration, not competition in this effort, and driving things forward. And computational storage is something that is fairly new as far as deployed solutions. It's been around for a while. The market is ripe for it. The data sphere is ripe for it. The ability to drive data in and not drive raw data out is the key of what's helping computational storage be successful. So from a what is next perspective, I throw this out as the call to action, if you will. Learn, participate, evangelization, and deployment. Those are the things that are going to make this thing happen. If you're interested in joining the efforts, we have the SNIA Technical Working Group on computational storage. There's a bunch of other working groups that are coexisting with this. You've seen a presentation, or we'll see a presentation if you watch all of them, on SDXI, which is a partner group related to memory-related activities. A lot of the presentations today, we're talking about persistent memory. That persistent memory is being driven in a lot of ways by the SNIA as well. So if you're not interested in just computational storage, join us, have some fun. It'll be a great opportunity. And don't forget, NVMe is also driving their computational storage task group. There's work to be done there still. We're creating the new command set and command structure in the next release of NVMe to help with this seamless plug and play capability of all of these products. So we look forward to having you join these efforts, and hopefully the information I've shared today in this brief presentation has given you something to think about, some ideas about what's going forward. And then as we go into the rest of the year, there's 3 great events coming from SNIA in the way of the storage developer conferences. These are the technology product conferences. This is where you get to get the deep dive in how these products work. All of the vendors I've shown today will participate in some way, shape, or form in that event, and you'll have the opportunity to learn more on the technical savviness and the uniqueness of these particular products versus this kind of where is the market today. So with that, I would like to say thank you. Again, this was the idea to give you a computational storage market overview, tell you what's going on in the space, let you know who's out there, and see if you're interested. Let us know. We'll help. Happy to have you join us. So again, thank you again. My name is Scott Shadley, VP of Marketing at NG Systems and SNIA board member, as well as the co-chair of the Computational Storage Technical Working Group. So if you want to know more about computational storage, give me a buzz. You can find me on Twitter or you can ping me on Slack.